RAM, yeah, random access memory. Yeah, very good. This is the part of the computer where variables are stored in the computer. It's actually stored in your RAM. This is the stuff that gets reset when you turn your computer off, right? Just it's not long-term memory. This is the stuff this is actually where variables are stored in the computer. Um, Raise your hand if you have 16 gigabytes of RAM on your computer. Maybe, not sure. Raise your hand if you have more than 16 gigabytes on your computer. How much RAM do you have? 32 gigabytes of RAM? That's amazing. I'm a little bit jealous. What kind of computer is it? Okay, desktop at home, 32. That's amazing. So you can store a ton of memory. You can do some crazy stuff with 32 gigabytes of RAM. Anybody have 8 gigs of RAM? Yeah, that's what I'm talking. Battery friendly, hopefully, maybe. Oh, nice. That's great. That's cool. What kind of computer is that? Okay, very cool. So inside of this random access memory, if we were to look at what is inside of this, this is what we would see. Zeros and ones. How about that? Zeros and like that's it. Zeros and ones. So let's talk about this a little bit more. When we talk about a variable, what is a variable? It's actually a location in memory. That's a variable. A location in random access memory with a name. It has a name where a value of a particular data type can be stored and retrieved. A little bit of a long definition, but let's look at this. This is just a location in RAM. That's a variable. We're going to be using variables a lot. We're going to store stuff in variables. We're going to pull stuff out of variables. We're going to do calculations with variables. But this is what a variable is. It's a location in random access memory. It's actually a location. It's got like a little address. This is where this location is. It's got a name, and the value has a particular data type. String, is it a number? It's got a particular data type, and it can be stored and retrieved. So when we talk about zeros and ones, we put 8 of these together, and it's called 1 byte. So 8 bits makes a byte. 1 byte of memory. 8 bits. How about that? And each byte can represent a value. So, for example, the value 0 is looks like this, right? Each bit is 0. So the entire byte means it's 0. What does 1 look like? This is what 1 looks like in random access memory. The 1 in the 1 box is a 1. What does 2 look like? 2. How about that? What do you think 3 looks like? Yeah, 101. Here's a funny shirt. There are how many types? But if you're in binary, this is called binary, right? We're actually in a binary operations here. This is 2, right? So a 1 and a 0 in binary says there are 2 types of people in the world, those who understand binary and those who don't. The other one that I take offense to is there are 2 types of people in the world, the ones who understand binary and those who have friends. I take offense to that. I don't know. That's definitely not true, right? Definitely not true. But that's binary. So the binary here is that 1 and 0. So here's 3. 1 is 1 and 2 is 2. So we're saying 1 plus 2, right? This is basically some product. We're taking this times this plus this times this. That is 3. This is how this is stored in memory. Here's 4, right? 1, 0, 0. Here is, what's this? 65. Very good. What's this one? What? Did you add those up so fast? You're good like that? Eli, did you say that too? Oh, you just looked at the PowerPoint. You just did your homework. Good job. Even better. Even better. Yeah, there's a shortcut here, right? This is just multiplying by 2 minus 1, right? If we go back here, this is 64 plus that 1 over there. If we go here, what's 2 times 128? That'd be 256 minus 1 would be 255. So what we do is we're just adding all of these together. So that's 255. So that means that from a byte perspective, what's the highest number we can include in a byte? 255. Yeah, very good. Okay, so let's look at this from a coding perspective. I'm going to pull open Excel. You're welcome to follow along, or if you just want to watch and kind of just see how this works, that's fine too. But I want to show you a little bit on this idea of a byte. So I'm going to open up my Visual Basic. I'll go ahead and make it a big one here. And I'm going to insert a module. So if you've never inserted a module, it looks something like this. I'll come over here to insert in a module, and this is where I'm going to write some code. Notice there's a module 1 here. This is inside of this book 1. So this code is going to stay inside of this Excel file. And let's just examine this idea of a byte here for a minute. I'm going to go ahead and create a sub. I'll call it sub variables. And actually, let me see if I can make this a little bit bigger so that you guys can actually read it. Let me go to a new font here. Let me go to, I think I want to do Microsoft Sans Serif Western. Where'd it go? Sans serif. And let's go, I don't know, 1824. Should we do 24? Let's see what 24 looks like. Is that better? Can you see that a little bit better? Okay, great. So we're creating a sub here. And let me create a variable. So we're going to use dim. And dim is the way to create a variable. And we're going to do a byte variable. So just like we had a byte here, this is a byte, which is 8 bits. We're going to create a byte variable. We're going to call it numvar. And I think it's important to notice that when we do this, this line right here, what's happening is that Excel is going to go talk to the operating system. And he's going to say, hey, operating system, I need some memory for this variable. And the operating system talks back to Excel and says, okay, here, use this. And it gives it a location in memory for this byte. And that's all that's happened so far. We're saying, hey, I need some memory. Okay, here's some memory. That's what that line says. Please. Oh yeah, good question. Did you do the insert module? And are you on a PC? You're on a PC. Windows? Oh, you're on a Mac. Okay, yeah. Insert module. And then I typed up here sub variables, open and close parentheses, and hit enter. And then it should type this in sub for you. And then I type this in. Grace, you're our Mac expert here, Grace. She's like, wait, what? Me?
Module is not an option.
Oh, go to click on
Am I in the wrong place?
no, I think you're right. Click on this window again. Now try there you go. I think it was still on your Excel sheet. Yeah, yeah. It's a little confusing. Sure. Okay, so what I want to look at here is this variable. And in fact, what I also want to do is I want to come over to view. If you click on immediate window here, view immediate window, and I'm just going to drag this up to the top. This is going to give us the ability to do some output from running our code. So for example, let's say I want to put something into this variable. I can do let numvar equal 5. And then I can do debug dot print. Remember what the two characteristics of an object are? What are the two? We talked about this last time. What are the two characteristics of an object? Well, I thought they were, but they're talking about something else. What are the two characteristics of an object? An object can have a property or a method? Close. Value would be a property. So you're close. So debug here, debug is the object. Dot print, do you think dot print is a method or a property? Methods is what something does, right? An object does something. So this is going to be a method. Print is kind of an action. It's printing, so it's doing something, right? You can also have properties, which are value, formula, color. Those are kind of the attributes of the object. So objects have methods and properties. In this case, this is a method, and we're going to print that num bar. And when we debug print it, it's going to show up here in the immediate window. So if I run this program, I'll run it line by line. I'll hit F8. This is going to create a variable, just like we talked about before. It's going to go say, hey, go grab some memory from the random access memory from the operating system right there. And then this line, after I hit F8, it's actually going to go put a value into that location in memory. So this line created the variable in memory. It like allocated space in memory for the value. And this line here is saying, okay, now I'm going to go put some value in that space in the memory. That's what this is doing. So now I can hit that. I'll run this line next, and it's going to put 5 up there. It says, oh, we just stored 5 in that variable, and now we just retrieved that value from the variable, right? Why doesn't it print numVar up here? When I say debug print numVar, why doesn't it just print numVar out? That's it, because it recognizes that it's a variable. Yeah. It says, oh, this is actually a variable. Go pull that 5 from that location in memory. That's what that's what I really want. So it recognizes that it's a variable. Please. Go to view, click on immediate window. Yeah, and then mine came down here and I just clicked and dragged the title bar wherever I wanted it. So I could pull it out here. I just dragged it up here so I could see it on top. Okay, what about if I do this? What if I do let numVar equal 0? Is 0 a valid number here? Yes, I like the hesitation. It is. So it's printed 0. So we can store 0. Okay, what if I put 255 here? Yes, why? Why is that a valid number here? Very good, because it's a byte. We know that the limit to a byte, like we talked about before, right? This is all ones. So that memory is going to say, okay, everything's 1 in this byte. The value of that is 255. Okay, what happens if we do 256? Nice. If we click this and try to run it, let me take this out. It's going to give me an error. It says an overflow error. What does that mean? We're trying to put in a higher number than what this data type can hold, right? So as a byte, because we said I want a byte, I'm just as byte. That's like we're telling it what type of data we want this memory to be, this variable to be, and that's going to limit it to 255. So if you see an overflow error in your code, it's probably a problem with what you're trying to put into that variable, right? It's overflowing. There's no room. We can't do 255. It's an overflow. What about this? What if we did -1? Maybe it should be called underflow or something like that. Is that better? Better word for it? But it's overflow. It's the same similar type of problem, right? It's not going to fit inside of this data type. It can't be expressed. It just doesn't, it doesn't compute. Nope, I don't know what you're talking about. It's not going to fit. Okay, great. So this is, let's see, is there anything else in here? What we can also do is we can say, what if we wanted a variable to store a value from Excel? So if I have a value here in Excel, let's say Nephi, an E5, and I did something like this. I referenced E5, What do you think is going to be stored in numVar?
It tried to be NePi, but since it's not a variable, it wouldn't pull it up.
Good question. Let's check. Type mismatch. Very good. That's exactly right. So that's what you are so smart. It recognizes, wait a minute, a byte is actually limited to integers, 0 through 255. So it doesn't accept NePi. NePi is a string. It's characters, right? Those are letters, not numbers. And it says, nope, that's type mismatch. And a type mismatch error usually means you're trying to put numbers into strings or strings into numbers. VBA is actually very forgiving. You can put you can put numbers into strings. VBA will accept that, but you can't put strings into a byte type or any kind of number type of data. Okay, very good. What if I did this? What if I said 5 here in this cell? Let's do 15. Now when I run this, it recognizes, oh, E5 is the cell. I'm going to take the value from that cell and put it into that variable. And that variable numVar contains that number 15. And we just saved the value there and we retrieved that value from that variable. Okay, very good. Any questions, comments, concerns? Hunter, you on it?
Talk about it. I wasn't paying attention, so I'll talk about it.
Should we let him ask the question or should we keep going? Oh, all these guys are like nodding their heads yes, Hunter.
I wanna see the embarrassment.
No, no, it's probably, I bet other people might have the question too. Question.
So I understand how it's getting certain values,
Yeah, debug.
but I'm wondering if I wasn't paying attention when you explained what all of that means.
All of this mumbo, you just called all of this?
Debug, print, and what is it?
Debug is the way we're going to retrieve the value from this variable and print it right up here to this immediate window.
Okay.
That's all that is. We're just going to debug print. We'll use debug print a ton in this class. And mostly we'll use it when we're writing code to help us know, is the value in this variable what we expect it to be? You know what I mean? So we're going to use that a lot. I don't know, is that helpful? Eli, help us out. Yeah, what is dim? That's a good question. What does dim mean? That's just the way you do it in VBA. That's just the way it is. This is the way.
Yeah, we're good.
Okay, great. Thank you, Eli. Okay, so let me go back to the slides here. So we have a byte, but it turns out there's more than just a byte. What if we put 2 bytes together? So far we're good to go from 0 to 255, right? If we add another byte, does that mean we're up to 510? No, very good. When we add a second byte, because each one of these is doubling, this is how you would do 256 with a second byte. This is 1000. Okay, so now, so we can start to see how the numbers will grow. We can start to see how the memory in our random access memory is going to allocate memory for a variable. We can call this a variable, and we can store 1000, the number 1000, in memory using 2 bytes. And then the question is, well, wait a minute, what's the limit? So the byte, the range is 0 to 255. And then there's another data type called an integer data type. So instead of saving something or creating a variable using an as byte type, we can create a variable using integer type. And when we do that, we have 2 bytes. What's the range of an integer variable type? We'll get to that in just a second. So what we have so far is we have a byte and we have an integer data type. That's a type of data. And there's a whole different there's a whole list of reasons why we want to have different types of data when we create our programs. If we go back to the memory, when we declare a variable, remember it's a location in memory. Each bit in memory has a location. This is actually a location in memory. This is a base 10 location. This is like the URLs on a website, right? That's a location, an address. Each bit in memory has its own address. And the operating system is going to tell Excel, this is where that memory is at in memory, in this location. So this top number is a base 10. This bottom number here is a base 16. And this is also known as hexadecimal. So when we deal with memory, each memory location has a specific hexadecimal related to it. Notice these two next to each other. We have 4.8 and then 4.9, or we have an F0 and an F1. So there's some increment here for each bit. So each of the 32 megabytes of memory has a specific location. And that location is going to be tied to the variable that we create. So if we dim x as an integer, it's going to say, okay, here's the location of this variable in memory. And it's going to return x has this location. And it's going to reserve 2 bytes of memory. That's what happens when we run this line in VBA. It gives us a location and how much memory it allocates right there. Isn't that interesting? It's a location in memory, and it says how much it's going to allocate. Okay, so how do we represent a negative number? Turns out that we take and we use subtract it. So if we take 1,000, here's what 1,000 looked like. 512 plus 256 plus 128, 64, 32, and 8. That gives us 1,000. The way this is actually stored is we say, we're going to start at negative 32,768. We're going to add this number to it, and that's going to come out as a negative 31,768. Isn't that interesting? So it turns out if you put these ones in here, and start with negative 32,000, the actual number returned is negative 31. Here's another example. Here is 32,767. Where did I get this number from? This is on this base 2, right? We're just doubling all the way up to this number. And all of these are ones. And the sum product of all of these together is 32,767, right? If we start at negative 32,768, which is this number, this is like the most we have, we add 32,767 to it, it gives us negative 1. So if you go into your memory, your random access memory, and you type in negative 1 into your computer, it's going to store these 2 bytes together, and it's going to store 0 for this first one, 1 for all of these other bits, and that's how it's going to record negative 1 in your memory in your computer. Chris. Yeah, you'd think it would, right? It's really just a bit. You could do bit with 0, 1. But no, they use 2 bytes. That's just the way they do it. That's another one of those weird things. Because of the underlying structure, it's easier to use 2 bytes in the long run than it is for a bit. Because all those numbers are still in 2 bytes. Okay, so if this is 32,768, we have 1 here, then all these are 0, but we have to add it to negative 32,768. The real returned value is going to be 0. So this is what 0 looks like in your memory. From an integer perspective, if it's an integer data type, we're going to say negative 32,768 plus all of this is the actual returned value, which is 0. Eli.
So how come you could find 0 with 1 bit, with 2 bytes, you have to put 1?
Because it starts at the negative and positive of this, so it's negative 32,768. So you have to add that back. The way to add that all back is with this being 1, because that would be 32,768.
But if you just do 1 bit, nothing.
Yeah, that was kind of Chris's.
Also 0?
Yeah, the convention is to use 2 bytes instead of 1 bit.
Yeah. The word to be made is 0 with 1 bit, right?
Right. Right, if you're using a byte, this is for integer type. Integer type has 2 bytes.
Okay, so specifically if you're using.
Correct.
it's how it shows.
This is how it's recorded in memory. That's right. Yeah, please.
So I wanted the 32,768, I would just put 2 right there. Right there.
Wait, why can't you put 2? That's a great question.
Because it's only
Oh.
zero and one.
That's it. That's it. And that's it. No, this is pretty complex stuff. I don't expect anybody to master this. This is all.
So I do like 1 all around. Wait, then now.
Well-
So you have to add another byte in order to get to that?
You got it.
I still don't get it.
Well, if we go back to this other one, let me see if here's 1 byte, right? What's the min and max of bytes? What's the minimum you can put in a byte?
It's like double minus 1.
0.
So it's the minimum?
Yeah, the lowest.
2 different types of variables. Right, the maximum.
Yeah. So the range of a byte variable, and a byte is a specific data type, right? We're saying 0. So if everything is 0 for 1 byte, oh, sorry, I went the wrong way.
Is there anybody who the class because he didn't pass the class?
Nobody's repeated this class for me,
Good.
which is more reflection of me, by the way. Oh yeah, for sure. So here's 1, right?
This is how it's shown. We can't go past 255.
No, you're good. Please.
No, Hunter, I want to help.
I switched it.
Okay, I feel justified in asking questions because when I ask, does anyone understand this? Nobody raised their hand.
They all raise their hand. It was like this.
Come on, guys. Wait, so in VBA you never have like 1 byte. It's always at least 2.
Yeah, we're getting to that. Let me answer that in a couple more slides. Elise?
Numbers on the top, it's the 128.
Yeah.
That's the only question. I don't know. Can you explain again?
Yeah, sure.
1 byte has to be.
So
Yeah.
did you want to answer or did you have another question? Okay, hold on. So each one of these is a bit, right? These are going to be 0 or 1. That's how it's going to be stored on the actual chip. There's a little space. Yeah, that's on the RAM. It's almost like an on and off switch on the actual chip. So there's all kinds. It's 32 billion. I mean, it's all zeros or 1. That's exactly right. So what this is this is a way to track the numbers. That's part of this base 2. So the base 2 model says, let's take 2 times whatever the previous square was, right? 2 times this, 2 times this, 2 times this, 2 times this, 2 times 2 times 2 times 2. So it turns out that this is like the numbering system, right? Right. Here's 1, here's 2, and here's 3. So we're taking this 1 plus this 2, and that's 3, total of 3. That's like the number 3. That's how 3 is stored in memory. 3 is like the value, like 3 plus 3, 3 plus 1, like the number 3.
Why now it's like all zeros? Like, oh, this is what's going on behind. Oh, I think it's like 3 plus 1. Remember that one is like, well, we get one. You're right.
I can see what you.
No, it added to 1 because it needs to start from the beginning, right? But why 1 to 64 right away?
Well, that was just another example. I was just doing another example.
Say as soon as they're like at 0 again at 1, like they need to start again.
Yeah, exactly. If you were going sequentially, then they have to go back and add 1 to that 1, right? Yeah. That's exactly right. So if you fill in 1 for everything.
But I get where you're getting.
Okay, great.
Okay.
Yeah, good. So you have 1 byte, and then if you add another byte to another byte, if you have 2 bytes together, all of a sudden you can get to, let me see if I can get to it.
Yeah, can be like.
This is where I wanted to go to. So for a byte, you can go from 0 to 255. Meaning, and I like what Brennan said earlier, if I put 3 into a cell, if I put 3 in a cell, that 3 is going to get stored into memory 0, 1, 1, right? That's how it's actually stored in memory. Right, right. 0 to 255. And the integer data type goes from negative 32,768 to positive 32,767. And the reason is because it's taking 2 bytes together, right? And this is how that looks in memory. So we have these 1, 1, 1, 1, 1, 0, 1, 0, 1, 0, 1, 0, 0. And that again goes back to these idea of these numbers, right? In these boxes, this is going to be a number inside of this range. I can't remember what the number was. I'm just picking examples, random numbers.
So I don't understand what this range is. You know what I mean? Like mathematically doesn't make any sense. So,
Yeah, see this 32,768?
oh, so it would be like 18,000 something something, 18,200 like 40.
Yeah, exactly.
minus-
Yeah, exactly. Yeah, exactly. And so even though all of these ones are filled out, right? If you did the math on all of this, it's 65,000. But because it starts at negative 32,000, the highest we can go for an integer data type is 32,767. So that's the range. Okay, we're going to keep going here. I'm going to let you guys come back to this video later and rewatch it. Is that okay? I'm hearing a lot of chatter. I'm not sure if that's related or not. Is it related? Okay, good. Okay, we'll keep going. There's a couple of other data types we need to get through. Here's another one. Long integer. 4 bytes, right? We started with 1 byte. We're up to 4 bytes now. Here's the range. Negative 2 billion to 2 billion. Plus or minus 2 billion. This is called a long integer, right? And another one. Let's do another one. What about decimal values? So far we've only done integer values. How does Excel, or how does a variable get stored as a decimal? Well, there's 2 different options. One option is you store an integer and then divide it by 10,000 to get 4 decimal places. So for example, if we had 65,535, if we divided by 10,000, that would give us 4 decimals, right? So that's one way to do it. If we had 52,500, divided that by 10,000, that would be 5.25. So this is how decimals are basically recorded. Another data type is currency. This is a big one. 922 billion to negative 922 billion with 4 decimals. Look at that, 8 bytes. So we went from 1 byte to an integer to a long integer to a currency. 8 bytes. It takes 8 bytes of memory to store the currency. Right, it should be positive, yeah. Yeah, nice catch, Hunter. Hunter's on it. Hunter's on it. Please, Chris. Sure.
By curiosity, so you have 1 byte, 2 bytes, 4 bytes, and then 8 bytes. Like, which one represents the 1 to?
Oh, in this particular situation, I'm not sure. If I gave extra credit, I would have you go do it for extra credit, but you can do it for non-extra credit too, if you want to. But yeah, basically it's saying, I mean, you could probably figure that out, right? If you wanted to, copy this into Excel and kind of trial and error it. I don't remember off the top of my head which one it is, but you could figure that out. The other option to represent a decimal value is to use a portion of the memory to just say where the decimal goes. So instead of doing the divide by 10,000, you take the first 4 bits and say, okay, here's the actual number after this first 4. And then we want to say this first 4 bits says where the decimal is. This is 1 decimal place over, right? This is 2 decimal places over. Take the same number value here and just move the decimal over 2 places. This is 3 decimal places over. This is, how many is that? 12, 14, 15 decimal places over, right? Notice how the 3574 doesn't change because that's all the same value of this down here and this up here. What changes is the decimal. So we're saying let's take 4 bits out of this 2 bytes of memory, and let's just say that's what the decimal is. 2 decimals, 3 decimals, 4 decimals, and then up to, what is that, 15 decimals? Here's another one, single precision floating number. Look at this, 4 bytes up to how many is that? I don't even know. I can't even count that high. This is a mass. Is that the size of the national debt? Maybe. But notice it's only precise to 7 significant digits. This isn't, there's not enough memory here in this type to keep track of everything, all of the significant digits all the way down. It's saying only these first 7 are actual digits, right? And then everything else is basically rounded. You're basically rounding it to the first 7 digits. Double is double precision floating point number. So it's saying instead of 4 bytes like a single, double is 8 bytes, and you can get to this level of number, 4.9. How many? I mean, I don't even know how to say that number. But again, only precise to 15 significant digits. Okay, so who can remember all the data types so far? Byte, integer, long, currency, single, double. There's no triple. That's great. You guys got them all. Good job. There's some more complexities with the single and double, but conceptually, this is what's going on. And then how about this one? How does VBA represent true and false? 0 is false, -1 is true. Isn't that interesting?
What about 1? Yeah.
1 is not necessarily true. -1 is true. And part of that goes back to the idea of how -1 is represented in the memory, right? Correct. In terms of how it's represented in memory, whoops, I went too far. It's -1 and 1. -1 is true. This is how this is represented, right? 2 bytes. You've got a 0 bit here. Everything else is 1. And that equals -1. That's true. False is 0. 1, 32,768. Because we're going to say -32,768 plus this value is equal to 0. And that's the way true and false are stored in VBA. That's the data type. True and false are actually sort of 0 and -1. Okay, so we've talked about numbers. By the way, Boolean, isn't that a cool word? Where does that come from? Anybody know? There was a mathematician whose last name was Boole in the 1800s. And he was the one that's kind of the founding father of logic. True, true, false, true, and false, false, true, true. And so they named this Boolean logic after him. Boolean is the data type. And there's only 2 options, true or false. And that's a Boolean data type. Okay, what about a date? It turns out that VBA stores the number of days after or before December 30th, 1899. Isn't that interesting? What a day. What a great day. So they take this date, December 30th, 1899, they add the number of days after it, and that's where this 27,945 comes, is this number right here, right, in memory? And that equals July 4th, 1976. That's how that's stored in VBA, is the number of days after or before that date. Basically, I think VBA just picked up a random date. But that's the date they use. I know, you're like, wait, what happened December 30th, 1899? I have no idea. I don't know. Is it on Wikipedia? Should we check?
I was just wondering, did you pick up a random number or the system pick up?
I don't know. I can't tell.
Nothing.
Helga Ingstad. Yeah, you got me. I don't nothing.
Yeah. Well,
But that's the
why they
date they
picked the
chose.
number.
Yeah, that's right. Maybe that is fine. That's right. Question, Chris?
Here we go past December 30th. Tuesday, and then do it each negative number.
Very good. Excellent. That's exactly right. That's exactly right. Very good. Okay, date and time. So we have the date. What about the time? Time stores a fractional number of a day. So if we wanted to know what 9 a.m. was on July 4th, 1976, it stores that as 0.375 of a day. That's how that date and time is stored in VBA, is a fraction of a day. So the day is 27,955 days after this date, and the time is 0.375 in the morning. In this case, it's 9 a.m. So there is a date value type, a data type called date. It's another variable type. And the range here goes from midnight, January 1st of the year 100 to December 31st, 9999. How about that? And it's 8 bytes. It's 8 bytes to keep track of that. Okay, so we've done numbers. What about names? How does VBA represent a name? It turns out each character, each letter, is mapped to a number between 0 and 255. So here is the value 65. Yeah, we'll see that. That's a good question. Here is 65, and 65 is a capital A. So this is in, if you look at this, this is the same thing. I'm just turning this sideways. You have this value to this value, right? 1 here plus the 64. So 64 plus 1 is 65. Internationally, the international language for letters is 65. Every computer in the world knows that if you store a 65 in a string, it's going to be a capital A. So what you can do is you can create long strings like this. So A is 65, lowercase d is 100, lowercase a is 97. Notice how there's a different number for lower and uppercase. M is 109, S is 115, comma is, what was it, 44? Comma is 44, space is 32. So we store each one of these characters as a number, and that number gets translated into a letter. And here's how it gets translated. Using this American Standard Code for Information Interchange, the ASCII code. If you've ever heard about the ASCII code, that's what this is. This is 65, so it goes to this table. 65 is a capital A, right? 100 is a lowercase d. A is 97, a lowercase a. So this is how all of those letters in your computer are recorded in memory, is through this ASCII table. This goes up to about 127. These are generally the same. The total ASCII table goes up to 255. And if you ever gone to a website and you get weird characters on it, part of that is because the operating systems have different ASCII translations after about 128. They get weird. They just change. Right? If you think about all the languages and all the different types of letters that exist out there, there's all kinds of other characters that are non-standard after about 127, 128. So that's where some of that, the weirdness of those websites comes in, is when you're looking at beyond the 127 range. Now, also what we've done is the everything in the number data types that we've talked about so far today is a fixed length. What's interesting about a string variable is it's a non-fixed length. So what they do is they take some of this memory and they say, okay, 4 bytes of overhead, we're going to tell you how long this string is as a part of the memory. Because it could be John Adams, it could be another name, Johnny Appleseed, right? And so this first 4 bytes of the memory is saying how long is this string. A string is 4 bytes plus 1 byte per character. And how does this work out in memory? Each one has a memory address. So when we run this line here in VBA code, dim name as string, we're creating this name as a variable with a string data type. The operating system goes to the memory and it says, okay, how about right here? Here's an address. I'll use this address. I'll give you 4 bytes. It turns out 4 bytes is the overhead with a 0 length string, right? Because there's nothing behind it. And it says that's the location. Then when you go into the code and you actually say, okay, now I want you to put John Adams into that variable. Then it says, okay, I'm going to go find a place where I can actually fit all of those characters into a string of 1s and 0s. And that's the new address. So this becomes the new address once you put actual data into that string. So the first time is when you create the string variable and it sets this, it creates memory this way. Then when you put memory into that variable, it goes and says, okay, now the variable's down here in this memory, and this is where the address is. Now let's get into a different kind of variable. These are called objects. And objects, they're a little bit more complex, but it's just like a variable in the sense that we can store all of this information about range 2 in one specific location in memory. All this continuously. We can store its address, we can store its formula, we can store the value, the column and the row, all of this together as one object, right? So VBA recognizes all of this information as one continuous, it's one object. That's actually a variable name. And they're stored at a location in memory just like variables are. Here's an example of a range object. So we're saying dim RNG, that's our object name. As object, the operating system is going to say, okay, here's the address and here's the allocation, 8 bytes for this object. Then when we go and put something into that object, it's going to hold the memory address of this object. And it's going to refer directly to this object in memory. This object already exists in memory. What this does right here is it's like a forwarding address. It's going to forward this RNG to this range A2. It's important to understand that it's forwarding. It's like a forwarding address to this range A2. And now I can have a whole bunch of interesting things with the VBA code. If I have an object, I can have a property, right? Here's the property of this object. RNG.value is, well, this isn't accurate, I guess. This should be 8. But whatever the value is, it can remember that value in memory. Okay, so let's do some coding around this. Let me go back to Excel and let's do some examples here so we can kind of get our arms around this. I'm going to do another sub. I'll call this variables 2, why don't we? And let me dim a range as object. Let's see. When do we get out of here? 3:30?
Yeah.
Okay, so we got about 30 minutes. I'm going to create an object. So here is the statement that says, operating system, go make some space for me. Go allocate some memory for this object. And what I'll do is I'll set this range equal to range A2 in the spreadsheet. So if I pull up my Excel, A2 right now is blank, but I'm going to set this range object to range A2. And then let's just debug this. So I'll debug.print. What am I going to print? I'm going to print rng.address. And it's going to print up here to the immediate window. So let me run this. If I click inside of this sub, put my cursor in here, anywhere inside of this sub, and I can click on F8, or I can come up here and click on the play button, and it will run this, just this code right here, right? Whatever's inside of this sub here. So if I run this, we've created an object. Okay, so we created this object. We identified what that object would point to, in this case, range A2. And then we're saying, okay, give me the address, give me the property of this object, and put it in my immediate window, debug.print. And it did, A2. What we can also do, though, is what if we have more than one sheet? How many A2s do I have in this file now, in this workbook? I've got 3 A2s. So now what we can do is we can come here, instead of just putting range A2, I can say worksheets, and I can name a specific sheet. Worksheets dot range A2. So then if I come here to range 2, I mean sheet 2, excuse me, if I reference this worksheet and range A2 on this specific worksheet, it's actually talking about this A2, not the one on sheet 1 or sheet 3. So I can put a value in there. So let's do a dot value. And if I put an A2 on sheet 2, I can put in here 25. And if I put 25 in my A2 on sheet 2 and run this, we should do 25 up here. It recognizes the worksheet. Now, let's do a little bit more. What if I have multiple Excel books open? How do I identify that? Well, I can come over here before worksheets and I can say workbooks. And I can give it the workbook name specifically. In this case, I think I've got book 1 and book 2. So I'll just do book 1. So I can say workbooks, book 1 is the workbook I want. And sheet 2, make this a little bit bigger, is the worksheet I want. Range A2 on sheet 2 in workbook 1 is the one I want. So if I go to that particular workbook, that particular sheet, and that particular range, and I change that and I run this, then it prints out 55. What I can do now is, after I've set this range, this object, to a specific cell, one of the benefits of this is I don't have to retype all of this again in my code, right? I can just use this range property to reference that particular cell, right? I can do rng.formula. I can do, well, let's say it's not a formula. What if I did 25 plus 25? And I can reference the formula. There it is, 25 plus formula. I can reference the value. I can reference all of the properties of the object without having to write this every time in my code. So that's one of the benefits of creating a worksheet object. Okay, let's take this to the next level. Instead of an object type, I can do a range type. Let me do another sub range variable. And I can create a new object, and this time I can call it RNG as range. And range is like a subset of the object type. So object can be any object. A range is talking about a range of cells. It can be one cell. It can be a collection of cells. It can be multiple cells like this. A range is referring to a number of cells together. So if I wanted to do set range equal to, we'll just do the active sheet here. So we'll just do range A2. Then what this offers me is, if I type in RNG with a dot sign, I see this little menu come up. You guys see that? There's what's called IntelliSense. And this is VBA's way to say, okay, I understand what this is. You're talking about a range object, and a range object has this list of properties and methods. This is it. You can only do something within this list for this particular range object, because it's a range object. So I can do RNG dot, and I can, here's my address property. I can do address. I can do a whole bunch of stuff here. Borders, I can change the borders. I can do characters, I can clear it. Here's some methods. I can clear contents, I can format, I can change the column width, I can change the background, I can copy, I can count. All of these properties and methods of this object are now available to me if I do dot, which is pretty cool. So if I were to do a debug in front of this, debug.print, give me the range.value, it's going to print the value inside of this range, which is right now 55. Let's change it to 65. I'll run it, and there it is. So this means we've created a range object in memory. We've set up a pointer for this RNG as a variable object to reference range A2. And now we're saying, okay, go grab me the value of that cell, range A2, and print it up here to my immediate window. Okay, not bad. Anybody still with me? Hunter, are you close?
Sure.
Okay, great. Let me do another one here, and let me see if you guys can guess what will be printed here. Let me change it here. Let's say I wanted to do range A2. And once I set this range, there is a property named parent name. What is the parent of range A2? Anybody know? That's a good guess. What's the parent of a cell or a range? Yeah, very good. It's going to be the name of the sheet. That's the parent of a range. So when I say print me the parent name of this range, it printed me sheet 2. Very good. So now, if that's going to print this, let's do this. What if I do worksheets and I do sheet 1, because I'm on sheet 2, right? And I say activate that sheet, and then I do debug print again, but this time I say print the parent dot name. And notice how there's 2 dots in here. I don't know if we've seen the 2 dots thing yet, right? We have an object, RNG is an object, parent is it's a property of RNG, and then name is a property of that parent, which is pretty cool, right? So we can do these trailing dots. We can do more than one dot. What do you think it's going to print here is the question. So we know what this is going to print. This is going to print sheet 2 because we're in sheet 2 right now. We're saying this range 2 is the object. What's the parent? We know that that's sheet 2. If we activate sheet 1, and then we do the same call to the same object, the parent and the name, what will this be? Will it be sheet 1 or will it be sheet 2? Let's try it. Let me erase this, run this. Sheet 2, how about that? So activating a sheet is different than setting the object. How about that? So when you set the object to range 2 here, that's still the same object when you come down here. Does that make sense? Even though we activated sheet 1, notice sheet 1 is activated, meaning that's the one my active cell is on. That's what it means to activate sheet 1, is that it's moved to sheet 1, right? We said move the cursor, activate sheet 1, show me sheet 1. It turns out this range object did not change because we activated it. It would have changed had we reset this object variable to sheet 1. How about that? So there's a difference there between setting the range and activating a sheet does not reset the range. Please. Something like this. So if we would have said again, set range A2 after sheet 1 is activated, would that change the parent name? You think so? What happened?
So if we wanted to say there's sheet 2, sheet 1. The set range A2 first. So that worksheet.
Yeah, well, like she wants.
Yeah, we could do that.
Then like, it would mean the
Right.
same cell, right?
Right. The other thing was is that we started in sheet 1. So when I pushed play on this sub, sheet 1 was already activated, right? So by default, it's going to go the range 2 that's open. If we start on sheet 2 and run this sub, then we should see, I think, what you were originally looking at, which was sheet 2, because this becomes sheet 2 by default, because that's where we started to run it. Then we activate sheet 1, we redefine what that RNG object is. It's actually range A2 on sheet 1, and that gives us the parent sheet 1. Yeah, very good. So notice it wasn't the activation of the sheet that changed the range, it was our setting of it. And that's actually a good thing, right? When we're doing code and we're going between sheets, we know that we can set a range object on one sheet, do a whole bunch of other stuff, and go to different sheets and copy and paste stuff. But we know that that range object is still referring to the original range that we set up originally. So that's actually a good thing in the long run. Was there a hand? Was there a question? Was there some kind of anything?
You kind of answered it.
Okay.
Let's go something
All right.
else, like,
Why? Why, Brother Jamis? Why? Okay, good. Let's do this. Couple more things here. There's another object type called variant. Variant is a weird one. I would recommend staying away from it as much as possible. There's like a couple of times in your lifetime that you'll actually use it. It's important to understand it because a lot of times other people will use it when they don't know they shouldn't. And so you have to know how to recognize it and how to know what it is. But I'll tell you why I don't recommend using it. Variant is, before I do this, let me explain why I think you need to understand variant. Let me go back to this example. In this example, we were doing an integer, right? What's the range of an integer, by the way? Yeah, negative 32 something thousand. Very good. Negative 32,000 something to positive 32,000 something. Right, very good. What if I put in here 5.51? What do you think is going to come out? So remember, this is the one where we put in 0 here initially. That worked out great. We put 255 in here initially. That worked out great. We put in here -1, and that said, nope, that's oh, that's an integer. Sorry, that was the byte. If we put in here 65,000, what do you think is going to happen? Overflow. Boom. Can't fit that many, right? That's beyond the range. But what if we go back to the byte one? And if this is the byte is 0 to 255, what if I put in 5.51? What do you think is going to happen? This is not an integer, right? What do you think VBA is going to do? They rounded it up. Any respectable programming language would give you an error. VBA does not give you, and part of that is the philosophy of Excel and Microsoft in general, which is we're trying to help these people out, right? We want it to work, even if it's not exactly what you said. We're going to try to fit it. We're going to try to make it work. So you have to be a little bit careful. And variant gets you into problems in that sense, because Microsoft here is saying, yeah, I know you put in 5.51, but I can't really do anything besides whole numbers because I'm an integer type. So I'm just going to put in 6. And that's a chosen design philosophy from the very beginning, right? It's good intentions, but any respectable programming language would give you an error. So if we go back to this idea of the variant, a variant is anything. You can write a string in a variant. You can do a number in a variant. You can do a big number or a small number. You can do a decimal in a variant. Why wouldn't we use variant for everything? One of the downsides is it takes 22 bytes of overhead as a variable. That starts to be a lot. In this class, it really doesn't make a huge difference. But when you're running lots of code over and over and over, and you're using variants, it will start to slow down your system. If you want to make it a range object, you can make it a range object. If you want to make it a string object, you can do a string. The downside of a variant is Microsoft is going to try to do whatever it thinks you want it to do. And so you can lose track of the precision that you need in your work, in your code, right? You think it's right, you do test cases, and it comes out right. And you're like, oh, this is perfect. And then when you actually go use it, it's like the worst error to debug in your life. It's very, very hard to find, very, very hard to realize, oh, that's my problem. It's a variant data type. It will do things that you won't expect. It will do a whole bunch of things. So for example, let me give you another example of where things get really dicey. Let's do a variant demo sub here. Oops, let me do this one. And let's say I do dim x. Let's see, how much time we got? Let me do this. Dim x as variant. And let's do dim y as variant. And let's set x to 3. Let's set y to 4. And let's add them together and print them out. X plus y. Okay, so this is our sub. Bless you. Let's see, not this one, but this one down here. Oh, wait, did I not? Oh, wait. This should be sub. There we go. We need a sub, and then we need an end sub at the very end. And this is kind of the middle. And let me correct my spelling. Sub variant underscore demo, open and close parentheses. We've created these two variables, x and y. They're both variant types. We're going to put 3 in x and 4 in y. And we're going to print x plus y. What do you think is going to print out? $34. Dangerous. See the danger there? Partly because it's variant, partly because there's quotes around here. So we're saying put this as a string into variant, not a number. It's the same thing if we put hello there. I mean, basically we're saying put strings in here instead of numbers, and it would print hello there. But those kinds of errors are the kinds of errors that you get when you do variant. It gets a little bit hazy, gets a little bit, and the intent is okay, right? Microsoft is trying to say, okay, do whatever you want with this extra variable. But when you're in the code, my recommendation is try not to use variant because you can, it loses track. It's trying to do the best thing, but it often gets it wrong. Okay, one more thing, and then I think I'll let you guys go. There is another variable called constant. So let me write another one here. Sub constant demo. And we can do a constant like this. Const pi as single equals 3.14. What's the rest? Wait, do you know that, Jade? You were saying that with such confidence. I was like, what? All right, we'll do 1415927. How about that? So we can create this variable as a pi. When we say const like that, we can reference that pi anywhere in the code. And so this is like a permanent variable that never changes. We don't ever change it inside the code. And we can reference that, right? So if we wanted to do debug dot print pi plus 10, that would give us pi plus 10, right? 13.14159. So we can use that anywhere we want, please. No, not the single, no. The single was limited to what, 7 decimal places, 7 significant digits? 1, 2, 3, 4, 5, 6, 7, because that's 7 significant digits. Yeah. Yeah, it's a good point. In fact, if we wanted to increase that, if we change this to double, we would see more digits. Let me make this a little bit more clear here. That gives us all the way out to, I think it was 15 significant digits. So yeah, that's a great point, right? You want to keep track of how many digits you need to keep track of. If you wanted to do, what is that, 7 decimals plus 6 or 7 whole numbers on the other side, you know, that's